record on this computer. And yeah, here we are. So hello, everybody, and good morning, good afternoon, good evening, whatever it is, because there are so many time zones. So today I'm here with Luca Barze from SUSE, or should be SUSE. It really depends, because we are with how to say that properly. So Luca, it should be SUSE, right?
SUSE, something like that, yes.
Yeah.
The important thing is to not use SUSE, because it's what common people use to say. So SUSE.
Okay.
No, it's SUSE, okay.
Okay, SUSE as a German.
Yes.
And we are here to talk about multi-tenancy. This is our local, although not local, but virtual meetup, where we are talking about technologies, about Kubernetes, and just a brief reminder, what is multi-tenancy? So multi-tenancy is a way to share an underlying infrastructure of your cluster with multiple tenants. You can achieve that using a shared cluster or a shared infrastructure, as we are going to see today. And keep in mind that if you add in the time, please sign up on the meetup.com group. You can find us also on LinkedIn as CLASTIX, that is the company behind this meetup. And yeah, that's all. So I'd say that I can start sharing my screen. So let me check if I can do that. Share screen and desktop one. And here we are. I guess that everybody should be able to see the screen. Just 1 second, because I have to open also the chat. Where is the chat? Here it is. So here we are. So let's present. And today we are going to talk about Kubernetes, obviously, and SUSE, Rancher, and Kamaji. It's not loading, or is it just me?
No, it's not.
Wow, we are going well. At least it happened at the beginning, Okay, it doesn't like the full screen mode, so I'm sorry. We are going for just the presentation in this way, if it loads. In meanwhile, maybe Luca, if you would like to introduce yourself to our audience.
Yes. So hello to everyone. I'm Luca Barze, and I work as a pre-sale engineer in SUSE. And today we will speak with Dario about Rancher and its integration with Kamaji. We will explain what these solutions are and how they integrate with each other. Okay, so this is what we will talk about today. Dario, would you like to present yourself too?
Yeah, absolutely. So my name is Dario Tranchitella, although the surname is pretty butchered across the world, but it's okay. It's really hard to say that for non-Italian. And I'm technical advisor at CLASTIX. CLASTIX is the company behind Capsule and Kamaji, two open source projects that are addressing multi-tenancy in two different ways. Capsule at the soft level, so using namespaces, and instead Kamaji addressing in the hard way, so using multiple clusters. But well, yes, but actually nope. We are going to present that. We got an agenda and just also a brief overview of the rules of this meeting. So we are going to have a sort of quick question and answer at the end of the session. Please don't turn on your microphone. If you have any kind of question, write in the chat, and maybe we are going to make it less boring as possible. So time by time, I will check the chat and I'll ask the question directly to Luca. I'll try to answer them. And I think that we can start with the agenda. So Luca, would you like to take that?
Yes, for sure. So we will start explaining what we mean with multi-tenancy, and in particular, what multi-tenancy represents in a Kubernetes world. And we will go on, we will explain what multi-tenancy is within Rancher, and we will also give a brief overview of Rancher. Okay. We will later continue with Kamaji and how Kamaji can help us in different situations. Finally, we will have a really nice demo. And well, question and answer. It is written at the end. You can write them in the chat when you want, so that we will answer directly in the chat, or we will answer at the end, so as you prefer.
Yeah, keep in mind that, Luca, today you're the guest here, you're the rock star, so please be my guest explaining what is multi-tenancy.
Okay, so what is multi-tenancy? You can find the definition of multi-tenancy written in this slide. So multi-tenancy is a mode of operation where different entities share the same infrastructure or the same application. What these entities can be? For example, an entity can be a final user. Okay, so there is a single application or a single infrastructure which is shared between different users. So I am a user, Dario is a user, we are using the same infrastructure or the same application, and we are sharing the resources and everything else. Or an entity can also be a company. For example, I have a company, Dario has another company. Both companies use the same infrastructure, the same application, so that we can share the resources, the management, and so on. Okay, and another kind of entity that is possible is for example, different organizational unit within the same company. Okay, so we call every one of these entity tenant. Okay, so the word multi-tenancy. So multi-tenancy is a way of operation where we share the same infrastructure or application between different tenants. Okay, and why does it matter? Because if we share the infrastructure or the application, we are more efficient. Okay, because we are more efficient to manage our infrastructure. It is easier to scale the solution and so on. And multi-tenancy is becoming more important because if there is a single company which is offering the infrastructure or the application to other companies, the person from this company can become more expert in the technology and can manage the services in a more efficient way. Okay, so we improve the security, the reliability, the performance, and so on. Okay, and multi-tenancy is also important because, as we already said, it opens a new business model. It opens new business models. Okay, so companies can offer the infrastructure or the application as a service, so they can create a managed service provider business model. Okay, and where are we going in the infrastructure world? We are moving to Kubernetes. Okay, Dario, would you like to spend a few words about
Well, a few words will be really hard and challenging, but okay. I'll try, don't worry. We all know what is Kubernetes. So essentially it's the new black in regards to infrastructure management and cloud native, because Kubernetes, I'd say it's a sort of framework to build distributed systems. So in the end, we got software defined everything. So we got network, storage, ingress, load balancers, and blah, blah, blah. Keep in mind that the real benefit of Kubernetes resides in its architecture, because in the end, we got a set of controllers that are using a sort of reconcile loop. So instead of launching imperative commands, we got some manifests that are applied, and this reconcile loop constantly checks the drift between the desired state and the current state, and it acts to detect the version skews, well, the change skews, and starting from that is reconcile all our resources. You can think about the pods. So essentially, if I would like to get 2 replicas of a pod, for example, an Nginx or my application, Kubernetes is going to do that. So if one of the pods is failing, another one is going to be created. So with that said, keep in mind that Kubernetes is perfect if you want to achieve scalability, portability, resilience, and if you want to simplify operations, because everything is software defined. So it means that you can create your own components, infrastructure components as code. And keep in mind that we already have a sort of multi-tenancy in Kubernetes, because in the end, we got namespaces. What are namespaces? Namespace is a way to collect workloads in a sort of logic partition. So I could have the namespace for my customer A, customer B, and so on and so forth. But obviously, namespace is not enough. I need to put in place a set of policies and resource enforcements. Because if you think about that, everything is mixed in cluster, in a Kubernetes cluster, because we got the pods that are running on different nodes, and I don't have control over the nodes unless I'm using node selectors, affinities, tolerations, and blah, blah, blah. But keep in mind that sometimes a namespace is not enough. We got a product, an open source project that is named Capsule, that right now is getting big traction in the community. We're seeing a lot of adopters, a lot of end users, but today we are not going to focus on that, because namespace is one stuff, but we want to offer a sort of Kubernetes as a service solution. And with that said, oh, we are missing here the animation. But yeah, don't worry, go Luca. But okay, we can try to explain how it works.
For sure. So let's start with our Kubernetes cluster, okay, which is this icon here that you are seeing here. So we want to share our Kubernetes cluster between different entities, which are the two organizations that you see down here, okay? Two different entities, two different tenants, okay? So there are two ways that we can follow. The first one is shown on the left side of this slide. Okay, so we have a single Kubernetes cluster, which is shared between different organizations. Okay, so that we separate different namespace and we give different organizations right to different namespaces. Okay, and this is the way that we follow on the left side. On the right side, we follow a different approach. On the right side, we follow the approach where we create many Kubernetes clusters and we give the rights to this cluster to different organizations. Okay, so we give the rights to organization A to interact with cluster A, and organization B to interact with cluster B. Okay, so both of these approaches represent some difficulties. Okay, on the left side, you have the approach where we share a single cluster between different organizations. Okay, and what are the issues in this case? The issues in this case are related to the fact that within Kubernetes we have the namespace entity, as Dario told before, but namespaces are not enough for the having a clear separation between different organizations. Okay, and we have to be careful about what we are doing. We have to have different policies and so on. And in this case, we have tools that can help us. You see them here, our Rancher and Capsule. Okay, with Rancher and Capsule, we create an ensemble of namespace, which is called project in Rancher and tenant in Capsule, and we give these other entities, project and Capsule, to different organizations. Okay, so we can share a cluster between different organizations. Okay, we will not talk about this approach during this webinar. Maybe we will talk about it in a later webinar. The approach that we will talk about is the approach on the right side. Okay, so we create different clusters, okay, and we give different cluster to different tenants, to different organizations in this case. What are the issue in this case? The issue in this case is that usually creating, managing, upgrading, and so on, a Kubernetes cluster is not an easy and straightforward operation. Okay, it's kind of difficult to create and manage a Kubernetes cluster. Okay, but with Rancher we reduce a lot this complexity. Okay, so with Rancher we can create and manage in an easy way the number of clusters that we need. And after that, we give a different cluster to different organizations. It will work. Okay, so let's explain what Rancher is. Okay.
Yeah, Luca, if you don't mind, maybe what I can do is to just try to provide a brief overview why namespaces are not enough. You can imagine that maybe from the technical standpoint, using a shared cluster means that in the end, you are forcing all the customers to use the same CNI and using the shared node pool. And it could be cumbersome also from a security perspective, because maybe you have customers that are saying, no, I don't want to get my workload using the shared infrastructure because maybe I could have issues with the network, the storage, and so on and so forth. And with that said, also, you could have some customers that are saying, okay, I want to use Kubernetes 124, another one, no, I want to use 126, and it's a pain in the end. So to overcome these limitations, Capsule can try to kick there. But obviously, there are some cases like customers that are saying, I want to use my own infrastructure. So I don't want to use your workloads and, your nodes, but I want to bring my own devices, because in that way, I can be sure that my concerns are respected. And in the end, I can create also a sort of competence of cost, because I'm spending my resources. So creating a cluster per tenant is still legit, because it really depends. I'm sorry for saying that, because I have to show my seniority, but it really depends. And in some circumstances, you have to go in that direction, especially if you're offering a sort of Kubernetes as a service. But I'll pass the word to you to explain in a brief overview what is Rancher. Yeah.
In a really brief overview, Rancher is a powerful tool that we can use to manage and create different Kubernetes clusters. With Rancher, we make it easy to manage, configure, upgrade, and a Kubernetes cluster. And with Rancher, we can manage a lot of clusters. Thousands of clusters. It's not an issue. Okay, so Rancher does mainly two things, which are managing a Kubernetes cluster in a simple way and managing a lot of Kubernetes cluster. Okay, what are the issues? So in this case, so we have a powerful tool that can help us managing a lot of clusters. So we can create all the clusters that we want and give the rights to different clusters to different organizations, to our different tenants. What are the issues? The issues are shown in this slide, as you can see. So every time you create a Kubernetes cluster, you have different services that you need. For example, for each Kubernetes cluster, you need at least 3 etcd nodes. Okay, for sure, in a production scenario, you need 2 control planes and so on. You can, for example, join the control plane and the etcd nodes. Okay, this is absolutely fine. But there are a lot of resources that you need every time you create a Kubernetes cluster. Okay, so for example, let's suppose that you need, I don't know, 100 Kubernetes cluster. Okay, 100 Kubernetes cluster means that you will need 3 to 5 multiplied by 100 nodes more. Okay, so you will need 300, 500 nodes just to start. Okay, no one of these nodes will bring your computational workload that you need for your application. These are nodes that you need for managing your infrastructure. Okay. This is, let's say, an issue that Kamaji can help us solve. Okay, so
yeah, rather
if you want to
than
explain
absolutely.
okay.
Rather than talking about issue, I'd say it's a trade-off, because in the
It's a
end,
trade-off.
you're getting high segregation and high segregation of multi-tenancy, but obviously we are all technicians here and we know the pain in managing Kubernetes clusters. And also the management is really aware of the cost, because in the end there are no free meals there. So it means that we need to buy virtual machines, we need to pay the electricity bill, licenses, and so on and so forth. So Adriano, that is the CEO and founder of CLASTIX, created this term that I really love, because it's the Kubernetes stack. So you can imagine that maybe I need a Kubernetes cluster that is made of free worker nodes, but obviously I need to ensure that the control plane has high availability. So I need free virtual machines just for the control plane. And in the end, we are spending 50% of our workloads, well, of our node pools just for the control plane. And we are paying them a lot, because 50% is absolutely a lot. So with Capsule, we try to say, well, not Capsule, sorry, lapsus, it was a lapsus. But with Kamaji, we thought that we need to fix that. So with that said, we are going to introduce what is Kamaji. And I'll try to explain the 4 pillars of Kamaji. So we thought that Kamaji needs to solve the high density of hyperscalers are offering. So I want to decrease the resources and get more resources on my bare metal servers, or rather also virtual machines. It really depends also on the setup. And at the same time, I want to use, I need to switch off Slack. At the same time, I have also to shift the multi-tenancy from etcd, bare etcd, to a scalable data store. So it means that instead of having one etcd per tenant, I can use one etcd per multiple clusters. Maybe I can say I have a data store, so an etcd that is going to be used by a tenant, and that tenant is bringing 10 clusters. So I can use a unique data store using the schemas. Obviously, in etcd, we don't have the schemas, but we can have a prefix to the keys with the RBAC enabled on that. But keep in mind that we know that etcd got some limitations. So we implemented a sort of integration with Kine, K-I-N-E, that is a project backed by Rancher that allows to create a shim on etcd. So it means that we can use MySQL or PostgreSQL. So you can optimize the storage persistence in the end. And another nice feature is the Kubernetes inception, because, virtual machines are really great, but those are not real Kubernetes primitives. Obviously, you can use maybe a tool that is offering OpenVirt or maybe KubeVirt to handle the virtual machines in a Kubernetes way. But if you're running the control plane as applications in a management cluster, you're taking full advantage of the containers approach, because containers can spin up in a quick time. And also there is Kubernetes that is ensuring high availability. And I can do whatever I want with these primitives, because in the end, I got the famous, the glorious reconcile loop offered by Kubernetes. So with the Kubernetes inception, we are gathering a lot of flexibility in the day 2 operations. So upgrade, migration, scaling, and many other features. And last but not least, also because we are going to focus more on the demo, is the true multi-cloud. So it means that essentially what I can do is to have a cluster management that is this one that is running maybe on Azure. And then I have my tenants. So I have my customers that are asking, okay, I want to use Kubernetes, but I don't want to go to take care of the control plane. It's pretty common, because developers are developers. They want to focus on applications rather than doing infra stuff. Legit, I'd say. And maybe they are using different cloud providers. They are using different, organizations also on AWS, subscriptions and blah, blah, blah. Because obviously in bigger organizations, it's pretty common doing this FinOps approach. So you're paying for the resources that are you consuming. So using a shared cluster wouldn't be really feasible. So you're bringing your nodes and you're paying paying for your nodes, volumes, and so on and so forth. So with that said, we have our admin cluster here that is backed by Rancher, where we installed Kamaji along with a set of multi-tenant data store, and we got our tenant control planes. So Kamaji is just focusing on the challenging part of Kubernetes itself, the control plane, because if you think about the worker nodes, they are pretty straightforward because they are disposable, they are cattle, so you just need to spin up a new machine or rather upgrading those machines. And with that said, the control plane are pods, so they are stateless, they can be scaled out, scaled in according to your needs, and they are connecting to one or more data stores. And in the end, these control plane pods are exposed using a public IP. So in the end, you are consuming the API server as a service. Trying to provide just a brief overview because we are running out of time and I want to focus more on the demo. With Kamaji, we got really nice performances because we are saving a lot of resources because we need to use pods rather than virtual machines, so we can increase the density. Also, the provisioning time, you will see, it's really mesmerizing because we're talking something like 16 seconds. It depends also on the availability of the IPs, and also the update is pretty straightforward because in the end, you just need to swap the underlying pods that is made of the control plane. And also, we were able, during our latest benchmarks, to perform the reconciliation of 100 of control planes in just few minutes. So it's absolutely mesmerizing. If you ever installed Kubernetes in the hard way or using Terraform, Ansible, these numbers are going to shock you because in the end, when you have to install a Kubernetes cluster, unless you're using the AWS services or the Azure services, you're talking about hours of work. Unless you're using the managed services where maybe on AKS, you have to wait up to 10 minutes. With Kamaji, it's just a matter of seconds. Keep in mind that I'll try to explain these slides. We are working with Rancher, and we are really happy with that because in the end, we are seeing that the two solutions are working really good together because Kamaji are offering hyperscaling Kubernetes and Rancher is offering a seamless and unique integration with the multi-cloud management, multi-cluster management. And there is a nice feature that is Fleet that maybe Luca, you can just provide a brief overview about this.
Yes. So as I told you before, with Rancher, it's easy to manage many Kubernetes cluster. One of the most important features that we have in Rancher is Fleet. Okay, so what can we do with Fleet? With Fleet, we can bring our application to every cluster that we want, okay, with a GitOps approach, okay, so that we write every resource that we need for our application, and we put the YAML that define the resource, all the YAMLs that define all of our resources in a Git repository. And with Fleet, we say, take all the YAMLs that stay in this Git repository and bring them to this Kubernetes cluster, the Kubernetes cluster which is defined by a specific label, and so on. Okay, and this GitOps approach is, at least in my opinion, really powerful because with this GitOps approach, we increase the control of our application so that we know at every time what is running in our cluster, what version is, and so on. And it's really easy to have a clear understanding of the application running in our cluster. We will also have a really brief demo about Fleet. Okay, so
yeah, we are going with the demo.
We can start with the demo, okay?
So keep in mind that I already installed Rancher. So this is our Rancher. As you can see here, we got the local cluster, and I already imported 2 control planes that were created using Kamaji. But just to provide you a brief overview, we installed Kamaji using the marketplace offered here by Rancher, and you can get the CRD that is named tenant control plane. So with the tenant control plane, essentially you're defining in a declarative way how the control plane should be defined. And as you can see here, we can specify the name, the namespace, the add-ons, the control plane settings, the data source that we would like to use. So to try and also to answer to the question that we had in the chat, you can use a shared data store for multiple tenant control planes, or maybe having one-to-one relation between control plane and data store. It really depends also on the design of the multi-tenancy we would like to achieve. So we try to design Kamaji in the less opinionated way, just to fit any kind of usage. Then you got the settings for the Kubernetes configuration, like the kubelet group driver, the version, and also the network profile. So right now, as you can see here, we got our control planes, and we got 124 and 125. And what we can do is to check the YAML that we got here. So we got our add-on section, and maybe I can try to increase the size. We got our control plane deployments, where we are defining the amount of replicas with the strategy that we would like to get for our pods. And we are defining also the service. So right now we are exposing the control plane using the type load balancer. We are using the default data store, and we got all the Kubernetes settings along with the kubelet. And with that said, keep in mind that what you can do is using the UI to update the control plane, or maybe, since I really love using the CLI, you know, I'm a nerd. What I can do is to say, okay, kubectl get tenant control planes, and issue kubectl edit tenant control plane Kubernetes 124. I don't remember the last version of 124, so if you don't mind, I'm going to kind of node tags. Let's check for the 24. It should be the 12th version. So I'm going to check the version, should be here. And I'm going to say, okay, let's go for 124.12, or maybe let's play safe. You know, it's still a demo. I don't remember if the image is still there. So I'm upgrading the patch release. And as you can see here, the tenant control plane is entering in the upgrading phase. It means that we are getting the pods that are creating with a new replica set. And in a matter of seconds, you can notice here, we are already ready. So we were able to switch from 124.1 to, well, 124.0 to 124.1. And in fact, what I can do is to retrieve the kubeconfig. Kubeconfig is storing a secret. So what I can do is to issue kubectl get secret 124, and exporting with basic C4 code in this path, well-known path. And I can issue kubeconfig this kubectl version, and you can see here that we're running 124.1. And also keep in mind that this cluster, we are using a control plane, okay, but I also created a set of nodes, and these nodes are running on AWS. In fact, what I can do is to access the cluster management, entering in 124, and you can see here that we got the node pools. So we got these 3 virtual machines that are running on EC2. And in fact, if I issue kubeconfig kubectl get nodes, you can see here that we got our nodes running on AWS. And I got all the parts of my application. So Calico, we are using that for the CNI, the Rancher agents, kubeproxy, connectivity agent, and core DNS. But let's try to see in how many time with how many seconds we can create a new control plane. So I can use the UI, and that's really great, but you know, we are tech people, so we are going to use the CLI. So I'm going to edit documents, CLASTIX, Kamaji, config samples. Let's change the control plane, and I want to create Kubernetes 126. 126. You can see here, I'm going to expose that in load balancer mode. I'm going to use the C group file system systemd, exposing on port 6443, and using also connectivity. We're going to talk about that. So now what I can do is to have another pane watching the events and applying this control plane. So the control plane has been deployed, and we are waiting for the control plane endpoint. This is a public IP offered by Azure, and we are entering in the provisioning state. So we got our IP, we got our kubecon, kubeconfig, all the setting, all the setup stuff is done on etcd, and in a matter of seconds, times less words, we should be able, to see our control plane deployed. So 26 seconds, also considering that we needed to wait for the first 10 seconds of the IP. And what I can do now is to get, again, the kubeconfig for 126. And I can use this kubeconfig to retrieve the kubectl version. Demo. It's just a matter of the load balancer, the Amazon load balancer. Well, the Azure load balancer. Let me check. Netcat. No, Netcat. Oh, it's working. Now it's working.
Okay.
Yeah. We were much quicker rather than Azure. So with that said, we have our control plane that has been deployed, and you can notice that if I access again the local, I can see here my control plane 126 ready. So how can I bring my own nodes? If you remember, I told you that we want to create new nodes on a different provider. So we are going to connect nodes from AWS. And to achieve that, we can use CloudFormation. I created a CloudFormation template that is here, CloudFormation JSON, and it's the stack name is going to be Kubernetes 126, and I need to retrieve obviously the cluster API image I want to use, because I want to get everything already configured with kubelet, containerd, and blah, blah, blah. So what I can do is to say cluster AWS admin, and let's say I want to use Kubernetes version 126 in region EU West 1 using Ubuntu, and this is my AMI ID. So I just need to enter that. I'm going to create a T2 medium instance with 16 GB of root storage. And obviously, we need to inform how to get these nodes joining the cluster. Keep in mind that we are working to create a cluster provider for cluster API. So we are relying on the kubeadm bootstrap strategy. So what I have to do is to say kubeadm print join command, obviously using the right kubeconfig, because otherwise we are joining the wrong cluster. And here it is. So it means that at boot time, the machine must launch this command. And then what we have to do is to say, what's the name of the control plane? We said that it's going to be 126 in the namespace default, and security groups is going to be marked as default in these 3 subnets. And let's say 3 machines. So now I just need to review everything, and fingers crossed I didn't do something stupid. Let me check again. The public IP 1717, the image should be correct, the correct one. So now we can wait CloudFormation to create our machines. We are creating the launch template that is going to be used by the autoscaling group. And the autoscaling group has been created. And now what we have to do is to watch for these nodes joining the cluster. In the meanwhile, we can try to answer some questions. Run without sharing a data store. Well, you can do that. So what you can do is to say, I'm creating a data store, so one etcd cluster on a tenant basis. So you can do that, obviously. So the API server control plane is not part of the tenant Kubernetes network, or do you use some tunnel tricks? Keep in mind that the control planes are regular pods running in the management cluster, and then there is a trick that allows the communication against the workload nodes, and we're going to see that. Was there any downtime during the upgrade of Kubernetes version? Absolutely no. Because keep in mind that we are using the same machinery offered by Kubernetes. So there are the endpoints, and these are swapped to prevent downtime. Obviously, you can set your own rollout strategy. It really depends, because we are running, as you can see here, this is my management cluster, kubectl get pods. We got the pods, kubectl get deployment, and we got our deployments. So if you would like to get also an overview of how is made a deployment for a tenant control plane, you can see here that we got the containers, and we are using the official container images, where Kamaji is doing all its magic. So it's configuring all the add-ons, mounting all the secrets, and blah, blah, blah. And keep in mind that we got the API server, then we got the controller manager, should be kube controller manager, and then we got the kube scheduler. So keep in mind that we are using one pod running multiple containers. And as you can see here now, just a matter of seconds, we were able to get all our nodes joining from AWS. So 22, 28, and oops, if we go here in resources, auto-scaling group, and instance management, we should see the IP of this one. Let's check. 78. It's the wrong one. It's the public one. So 93, 93. Then we got 228 and 179. So now what we have to do is to install Calico, our CNI, because otherwise our nodes are not going to be marked as ready. I'm reusing the kube config. And you can see here that everything is applied. And now we can watch all the pods getting deployed there. And meanwhile, there is a question by Luca. After you upgrade the control plane, you have to create a new stack with the new Kubernetes version, or there is a way to upgrade nodes automatically too? Well, it really depends. Keep in mind that Kamaji is just managing the control plane. So what you can do is to create your own automation. We want to stick to Cluster API, because in the end, if you think about that, we are with Cluster API, you are using Kubernetes primitives to manage Kubernetes clusters. And we are doing pretty similar way, although in a different context. And with that said, yeah, using Cluster API, you will be able to upgrade everything on your own. But keep in mind that at the same time, we see that Kamaji is used in multiple ways, because there are some people that are using CloudFormation, others using Ansible, others using Terraform. So in the end, we don't want to be opinionated, because we want to create a sort of toolkit that can be used by organization to offer their own Kubernetes service. This next question is the etcd instance of the tenant is the same as the... No, absolutely no. We are not using the same etcd, because otherwise, you're creating a huge single point of failure. And that's one of the questions I always get during the presentation of Kamaji, because they're saying, okay, but you're ending up with multiple control planes running on a single shard cluster, and you're creating a single point of failure. But some people, they are forgetting that in the end, Kubernetes is self-resilient, and you can create clusters that are spreading across multiple availability zones. So obviously, you have to architect that in the proper way. And at the same time, keep in mind that what you can do is to avoid using etcd that got some limitations, and maybe using PostgreSQL. And with PostgreSQL, having an active and passive replication. So what you can do is to create also solutions to offer automatic disaster recovery, or I would say that, look, I'm missing a fault tolerance system. When a site is going down, the second one is coming up, something like that. I don't remember the name.
The disaster recovery, high availability.
Yeah,
yes,
that kind of stuff. Yeah.
Okay. Yes.
I'm sorry, I'm a bit tired today.
Okay.
As you can see here now, we got all our pods. And if you issue kubectl get nodes, our nodes are in ready state. And I want to show you a nice trick, because if you take a look here, the kubelet is announcing itself using the internal IP. So obviously, this internal IP is a private network, so I cannot access that. And you know that if I want to exec or retrieve the logs of the pods running in a pod, I need to get access to the kubelet port, but obviously we cannot here. So how can Kamaji work with webhooks, logs retrieval and execution in the pods? We are using connectivity, because if I issue again this kubeconfig kubectl -n kube system logs -f, the name of my pod, it's working. Essentially, there is connectivity that are a demo set running on the worker node pools that are providing a sort of reverse tunnel to let the API server, also by Kamaji, to connect and to retrieve the information required. It's something that is offered by the Kubernetes Networking Special Interest Group, and it's used in production by AKS, so it's battle tested and production grade. Okay, so in the end, we got our cluster, we got our nodes, but how can we add them on Rancher? So what we have to do is to enter in the local management, enter in cluster management, import existing, create on generic, and what we have to do is to define a name, Kubernetes 126. We say we want to create it, and we just need to apply the agents. So we can switch back here, and we can say, please use the kubeconfig of the 126 version and apply this manifest. And now we can wait for the pods of the Rancher getting deployed, and we could try to answer some questions. Maybe I missed something. So you use Rancher to spin up, oh, I lost it, to spin up kubeadm clusters. Is there a way to join K3 as nodes? So no, we are not using Rancher to spin up kubeadm clusters, but rather that's the duty of Kamaji. And Rancher is used as a multi-cluster management solution, using their agents to connect them and to access them. And is there a way to join K3 as nodes? Right now, nope. There is an issue that is market stale. And keep in mind that this is everything is open source, although there is CLASTIX that is offering commercial support on these solutions for production environments. But we can talk about that. And obviously, Luca, we can talk also about on the K3S support. Connectivity is not the same as being in the same network. That's not the question. Maybe I didn't understand properly. Is there a specific reason why you use kubeadm instead of other solutions like RKE or K3S, etc.? Well, we want to stick to cluster API, and cluster API are widely using kubeadm. And also, if you take a look to the documentation on Kubernetes, they are always referring to kubeadm, and it was pretty straightforward working in that direction. Also, keep in mind that all the CA management of Kamaji is done by kubeadm, so it's totally compatible. But in the future, keep in mind that we are driven by the community, so we are looking for feedback, and that's the reason why we are here talking about that. You can raise your feature requests, and we can discuss that. That's the power of open source in the end. K3S support will be appreciated. Love to hear that. Let me check if I missed something. Other question? It seems no. Yeah, keep in mind, I'm really sorry, people, because it's hard doing the demo and also trying to answer the question. So if I missed something, open your microphone at the end of the session, or maybe open your chat and type that again, and we can check that. In the meanwhile, let's check. Yeah, we got our connection here. So we got disconnected because it's restarting, as you can see here. But keep in mind that everything is working as expected, because what you can do is to access the previously provisioned clusters. And you can see here that we got our pods, our cores, we got our nodes, and obviously we got also our workloads, all the namespaces. And you can see here that everything is running. So essentially, this is a fully compliant Kubernetes cluster. And another nice feature is the fact that, as you can see here, if I issue kubectl get nodes, I don't see the control plane, because the control plane is managed by Kamaji itself. So you cannot hack itself. You cannot delete your API server pod and complaining about, oh, I broke my cluster, please fix that. So everything is automated also on the management perspective, because the update is done by Kamaji itself, swapping the pods, but also in regards to in the management cluster, let's say I want to generate a new certificate for the API server, or maybe I want to rotate the CA. Obviously, if I do that right now, the nodes are going to be disconnected because new CA means that I need to reprovision again nodes. But if I issue kubectl get secret, you can see here that we got all our secrets, like the service account certificate, the admin kubeconfig, or the API certificate. So what I can do is to say, I'm a bad guy, a nasty guy. kubectl delete secret of the API server certificate, and if I issue kubectl get secret, in a matter of seconds, Kamaji is creating it back using the original CA. So in the end, this is really powerful because you can use your own Kubernetes primitives to manage Kubernetes at scale. In the meanwhile, we should be able to get the clusters connected, and here we are.
Yes.
So running 126, created 4.5 minutes ago. I don't know, maybe Luca, if you would like to show, you can take over the screen sharing.
Yes.
To
Thank you.
Briefly overview what is the fleet integration.
Sure.
Yeah.
Thank you. So let's start. Let's share. Can you? Yes, I think everyone should see the.
Yeah, we can.
Okay, my window. Okay, so you see that we are using the same Rancher instance that Dario was using. These are the same cluster that Dario showed you before. So let's reduce it so that you can see better. So let's start from our menu, our Rancher menu, and let's go to continuous delivery. Continuous delivery is the fleet, okay, related to fleet, is the application within Rancher that make possible for us to have a GitOps approach in our clusters managed by Rancher. One of the most important things about Fleet is that with Fleet, we can manage all the clusters that we are managing in our Rancher environment. Okay, different solutions cannot do that. Okay, so let's see how Fleet works. So you see here, we have a simple repository, okay, where we have our simple application, this hello world, okay, and this hello world contains all the resources, all the Kubernetes resources that we need to deploy a demo application, hello world application. Okay, so we have our deployment, okay, we have our service, and so on. So let's suppose that we want to bring this application in a Kubernetes cluster. Okay, so we should download it and apply it to our Kubernetes cluster. This for sure does not scale, and it's difficult to reconstruct the operation that we made. Okay, a different approach that we can use is to use a GitOps approach. Okay, so we will do it now. So we will add a repository in our Rancher environment. Okay, so this name will be hello world. We will take this address here. Okay, we will go on a specific branch, which is ACR, and really important, we will specify the path that we want to take our YAMLs from. Okay, so it should be like this. Otherwise, Fleet will try to bring every YAML into our Kubernetes cluster. Okay, we could have defined some authentications and so on, but this is a public repository, so we don't need it. So let's go next. Next, you see that we can bring our YAMLs or to all the cluster in the workspace, or to specific cluster. Okay, so we can say bring this application to this Kubernetes cluster or to all the cluster in the workspace, or we can also do more complicated things. For example, we can say bring this application to all the cluster that match a specific label. Okay, for example, now let's start with something simple. So let's use a single cluster. Okay, let's create. Okay, now you see that there are 0/0 cluster ready. Okay, and in a few seconds we will see that let's go to the dashboard that we have a nicer view. That Fleet will realize that there is a cluster which is not aligned with its definition. You see 0 cluster ready. Okay, for this repository. Okay, now there let's say a resource is ready, not both of the resources that we have, a single resource, it will be the service. Now Fleet is down, the cluster is downloading the application of the image that we want to bring into production, and we will see our application running from our Rancher interface. Okay, so let's go here. Kubernetes 124 workloads. Okay, you see our applications, our deployment here. Okay, let's go to service discovery. Here we see our Hello World application. Okay, and so you see that if we need, for example, to modify something in our application, okay, let's suppose that our deployment YAML, we need to upgrade our application. Okay, so we will need to modify the version to 1.0.1, or we will need a new environment variable. For example, modify this variable here. We can modify our definition within our repository, and Fleet, we realize that there is a new modification of our YAML, and will bring the upgraded version to all of our cluster. Okay, so we see that we can bring in a really easy and powerful way the same application to a lot of cluster. Okay, this is just a short overview of Fleet. If you have any question, just
yeah, keep in
just
mind
write it
that,
down.
Luca,
Okay.
there was a nice question, not in regards to Fleet, sorry for that,
Okay.
Luca, but it was
No
in
worry.
regards to Kamaji. So is tenant migration possible? And the answer is absolutely yes. So keep in mind that Kamaji has been designed to be data oriented. So I've been site reliability engineer. I was managing a fleet of clusters. So what we did at CLASTIX was to transfer all this knowledge and all the caveats in an automated way. So essentially, if you want to migrate the data to a bigger data store or with higher performances, you can do that. So Kamaji essentially is copying the data from the old data store to a newer one, and is also ensuring that no changes are applied during the upgrade window. So to avoid, inconsistent state, automatically a webhook will be injected in the control plane, preventing any write or delete or update operation, and you're getting zero downtime and tenant control plane migration. So the end user during that upgrade window is still able to work with the control plane, obviously in read mode, but that's enough. And keep in mind that we were able to migrate a set of tenant control planes for a customer, and the migration phase was something like 2.5 minutes up to 5 minutes. It really depends also on the size of the HCD key values. Anyway, we are running out of time, so if you have any question, please go ahead and shout it out. Open your microphone. Final one. In Fleet, is it tracking a single branch, or you can have multiple branch setups for dev, production, etc.? Luca?
Yeah, yes, you can define the same application in different repository. Okay, so that let me share my screen just a second. Okay, here. Let's share it. Okay, so what you can do is define a new Git repository here. Okay, so it will be with the same address as before, like this one. Okay, and you can use a branch test, and you can bring the application in a different environment. Okay, in a different set of clusters.
Yeah, there is also another question, and please, Luca, if you don't mind, I'll try to answer that. So
Yes.
I can try to pass the hiring process at SUSE. Just joking. But why should I use Fleet when everybody is using Helm for packaging and GitOps for deployments? And honestly, I think that the reason behind that is the fact that you're using a single pane of glass for the multi-cluster management offered by Rancher, and you can create automation. So every time you're boarding a new cluster, Fleet is ensuring that all the changes, well, not the changes, but all the applications are reconciled on all the underlying clusters. So it's a deep integration between cluster management and application delivery.
Yes. And with Fleet, you can also manage a lot of cluster in a single instance.
Yeah.
So yes. And apart from this, Fleet is also working in a different way with respect to other solutions. So it is not working in a push way, but it is working in a pull way. Okay, so that if for some reason one of your cluster is not accessible by networking for, let's say, for a minute, okay, you don't lose the update of the cluster, of this cluster, okay, but when this cluster will be online again, it will be contacted by Fleet and the update will be made. Okay.
Yeah, the final question, and then I'm really sorry, people, but we have to leave because it's pretty late here. So how does Fleet work with config maps? If you edit a config map, it will be, will it only change it, leaving the deployment without the modification, I guess, or does it have some functionality like adding a hash to them?
Now, Fleet will, with Fleet, you have a config map in your Git repository. If you update it, it's like if you are doing the same as kubectl apply with a new definition. Okay.
So you have
Keep
to
in mind
perform
that if
the
you want,
rollout.
yes. So it's the same as using the Kubernetes primitives. And keep in mind that you shouldn't put secrets in a Git repository. Okay.
Yeah.
So the secrets should be treated carefully in a different way.
Absolutely. So, sorry, there are overwhelming questions here, and thanks, Tristan, also for the kudos. And keep in mind that we are going to be at KubeCon. Unfortunately, Luca, I don't think that you're going to be there.
No, I will not. Okay, but you can contact me anytime. Okay.
Yeah, we are going to share also the contact on LinkedIn for Luca Barzè from SUSE Rancher. My name is Dario. As CLASTIX, we are going to be at KubeCon. Remember, the booth number is SU23, and be there so you can meet the cluster busters, because we are the cluster busters, because we are able to catch the clusters that are keeping you awake during the night because you're on duty, on call. And looking forward to meeting you at KubeCon. And remember, obviously, to subscribe on our CLASTIX YouTube channel and join the meetup group. And feel free to get in touch with us for any questions in regards to multi-tenancy, Capsule, and Kamaji. So thank you so much and enjoy your evening. Ciao, ciao.
Bye. Bye. Ciao, ciao.